Okay, YouTube, in this video we're going to practice how to put a matrix into row echelon form by hand, and then we get to move on to how to do it on a calculator. But go ahead and start with this. Our goal, if row echelon form is what we want this to be in, is to get ones down the main diagonal here and zeros below. And we can see that this is some augmented matrix associated with the system, so really we'd be solving a system here. So our first goal would be to get this one here, I would say this one here. Let's move our first row and our third row so that this one here is basically up in the top left corner. So the first row operation that we're going to do here, or we're going to perform, and I would say there's going to be a lot of rewriting here. So write small like. I would say that this is 1, -2, 3, and 9. We can just put a little line here. And then our last row now would be this 2, -5, 5, and 17. With this middle row being -1, 3, 0, and -4. Okay, so we do need to write our work on the outside. So let's get used to this. We say row 1, I swapped it with row 3. And I guess because it doesn't really matter which one you write it next to here because you swapped them both, I'm going to write it next to row number 1. So now that we have a 1 here, what we're going to do is we're going to use this 1 to get zeros below it. So we've seen things like this before when solving systems with Gaussian elimination. And what I know is this. I can use this 1 and multiply it by the opposite of this number right here and then add it to that number. Or I can multiply by the opposite of this number right here and add it to that number, and it would eliminate the values underneath this 1. So my two row operations, I'm going to write them right now as this. I'm going to add row 1 onto row 2. And if you want to say, well, what did you multiply it by? Well, I multiplied it by 1 technically, because they'll already cancel my x terms if I add these together. I'm also going to add -2 times row 1 onto row 3. So you'll notice that these numbers here are the opposites of these numbers here. And I also know that because I have a leading 1, one good thing to keep in mind is that that first row is never going to change any longer. I also know this instantly, by the way. These both have to be zeros now. We use that 1 to do this. So now here's where we're going to take our time and we're going to go through and figure out the rest of these 6 values here. So if we took row 1 plus row 2, we get -2 plus 3 is 1. 3 plus 0 is 3. And we have to add our constants here also. 9 plus -4 is 5. Now, if we took -2 times our first row and then add it to row 3, we're going to have to multiply first this time. -2 times -2 is 4. And 4 plus a -5 is a -1. And -2 times this 3 is -6. And -6 plus this 5 is -1. And -2 times this 9 is -18. And -18 plus this 17, look at that, -1. Not that that's special or anything, but I would say that at this point, because we have these zeros here now, what our next goal is going to be is to get a 1 here. Now we're very lucky in this instance that we already have a leading 1. So now what we're going to do is this. We're going to use this leading 1 to cancel everything below it, to get zeros below it. So I'm going to do this. I'm going to say, well, what would I take times this 1 now to add on to this -1 to get it to cancel out? And I notice that they're already opposites. If I were to take the second row times 1, which is the opposite of -1, and add it to row 3, this row 3 would have a 0 here going forward. So that row operation would just basically be this. I'm going to say it's row 2 plus row 3 would give me a 0 here. And because my first row now is stuck, it's got a leading 1. We'll rewrite it. And because my second row now is stuck, it's got a leading 1. We're going to rewrite it. Basically, and I know I have a 0 here, and now I know, especially that I have a 0 here, there are only 2 values we need to find. So if we were adding row 2 to row 3, then we were really adding this 3 to this -1, which gives us a 2. And we were also adding this 5 plus this -1 is a 4. So now our last row operation would be to get a 1 here on this main diagonal now that we've gotten rid of all of these underneath these other 2 leading 1s. So we're going to take it times its reciprocal. So in this particular instance here, we're just going to take a half times row 3. Anything times its reciprocal is always 1. So looking at how quickly we can rewrite the system now, we'd say this is 1, -2, 3, and 9. Our second row is 0, 1, 3, and 5. And now our last row is 0, 0, and definitely a 1. We just have to say what's half of this 4, which is absolutely a 2. So looking at this now, we could say rewriting the system, what we have is something that looks like this. Equals 9. We would have y plus 3 times z is equal to 5. And we would also have that z is equal to 2. So in terms of our solution, let's go ahead and write our solution here. Solution, poor handwriting, I apologize. We know the z part of it. We know that z is equal to 2. And we also know that y plus 3 times z is equal to 5. So if z is 2, then we have y plus 6 is 5. And that y equals -1. And so now we can back substitute further and say, if I know these, then I can find out from my first equation here, which was just this, where I've removed the y and the z here. We'll put in y and z values as we know them to be. And we say this is x plus 2 plus 6 equals 9, or that x plus 8 equals 9. I can only think of one number that I could add to 8 and get 9, and that is 1. So here's the solution to our system, and that's how you put a matrix into row echelon form by hand. Cheers.